All right, good morning, students. Welcome back. So this is week 2, lecture 2 in the official schedule. We are going to get all the way to the end of 1.3, but I think we're going to have like one or two. It's going to be two. We're going to have two problems left that we won't finish today. So I will not officially be assigning 1.3's homework today, which means it won't be due in a week. It will be due a week from next class. So verbally, I'll go ahead and warn you that 1.3's homework will be due on February 2nd. Now, you could go ahead and get a jump start on it. All the problems that we do in class today that are similar to the homeworks, you could go ahead and find those and work on them. Like I said, we're pretty much going to do everything. In all honesty, I really could assign it today, but I'm going to be nice. I know a lot of us are still working on the prereq stuff, so focus your energies there. I'd like to remind you that your expectations are 6 hours of homework and studying per week for this college level class. If you're not meeting that minimum and you don't think you're doing well in this class, then that means, first of all, you got to put more time in it. But I don't want to spend too much time talking. I will remind you verbally that 1.2's homework was assigned last class, which means it's due on January 26th. And remember, all due dates are by 11:59 p.m. that same night. So there's no confusion. You know, if you say midnight, a lot of people will say, well, do you mean midnight the next day or midnight that day? Which one? So that's why we don't want confusion. So you'll hear me say one or two of these things again, but where we left off last time is we just kind of left this on the board to start writing your instructions as well as the example. I never read the example out loud, and you're going to find that I rant a little bit with these word problems. I always try and use word problems that I can relate to just a little bit in real life. So just be prepared for a rant or two. All right, let's go. And as usual, I'll be in the chat in a few minutes. If you have any questions, you can PM me there or just ask the chat in general.
161, we're going to go ahead and dive head first back into where we are with 1.3, models and applications. So we already showed all this last time. We may have even shown the actual example. I think we did show it, but we didn't really get into working it. So as a reminder, with these word problems, and it's not going to be something we do a ton of throughout the course, but we will have word problems peppered out in the material here and there. So again, just the kind of general synopsis of how you should approach them. Read the question, read it again, read it 3 times if you have to. Learn what it is you need from the problem and what it is you don't really need, because a lot of word problems will have extra information. A lot of them might draw out some of the items that you're supposed to be extracting from it and make it sound a lot worse than it actually is. And sometimes it can be a little more complicated, of course, but you have to read and then read it again and then read it again in some cases. Then you can go and identify what you know and what you don't know. You want to give these labels. So you want to say, all right, I know that there's 3 apples, and then I know that there's an unknown amount of oranges, so I call it X, something like that. Or maybe the number of oranges is the number of apples plus 7, so then it's something like X plus 7 if the other thing was X, as we will see moving forward. Use your words, as our parents tell us. Write out your equation in words if you have the ability to, without going straight to the algebra version of the equation. Instead of writing 3x plus 5 equals 7, write out what that would be in words as the problem kind of lays it out for you. Then you can actually put your knowns and unknowns into an equation, solve it, and check it. And we said that checking is usually more of a does it make sense aspect, not necessarily plugging the numbers back into the equations that you already solved. Yes, there can be an element to that, especially if you're a little weaker on the algebra side of things. But with word problems, the checking is generally more of a, does this answer actually make sense? Does it relate to everything else? For instance, if we were doing a problem talking about the traveling speed of a car and we get an answer of 6,000 miles per hour, that wouldn't make sense because our problems are generally pretty real world context. So your answer should probably be somewhere between, 20 miles an hour and 60 miles an hour, maybe a little more than 60. It could go down to 10 if we're dealing with heavy traffic. But 6,000 miles an hour sounds a little ridiculous. Versus if we were talking about the speed of an airplane, if you got an answer of 5 miles an hour, again, that doesn't really make sense. Airplanes generally go much, much faster. So long as we're not talking about paper airplanes, that would be another scenario. All right, so I've got, I think, 4 examples typed up, mostly kind of extracted from the textbook um, in terms of similarity. So I'm trying to give you things that are similar to what you'll deal with in your homework and what you'll deal with in your test. Um, Also, let me know if the audio, if my voice kind of goes in and out, or if it sounds really messed up at all today. I was having some issues yesterday. I think it was just with my internet and not Zoom. But just always let me know if anything like that's happening. That way I don't end up recording a bunch of fuzz, because then that's pointless, right? Okay. So out of 3 major colleges, oh wow, that is not written very well. Out of 3 majors colleges offer. That's what it says. I was just getting my words backwards. Psychology, business, and English. The business major on average makes $8,000 more than the psychology major, and we're talking about in a per year situation. And the English major makes on average $3,000 more per year than a psych major. Okay, so this is talking about on average. This isn't talking about right out of the gate from college. This is talking about on average after people have been in the career 20, 30 years. So you might say an average person with an engineering degree might make, say, $75,000. But if you're coming fresh out of college, you're probably in the 50, 60 range, if not less, depending on your company. And that average might even be more than 75. Not the point of the problem, just saying that this is average. And we don't even say what type of average, whether it's a mean, a median, or a mode. But we're getting past the point. So business majors make about 8,000 more than psych majors. English majors make about 3,000 more than psych majors. And this is actually really nice that both of those compare to the psych major. That's going to simplify things for us. Then they say if the sum of these 3 majors averages is $116,000, again, per year, what is each major's individual average? So we're trying to make a statement like, oh, the English major is going to make 22,000, the history major is going to make 81,000. And again, I'm saying random numbers and things. So we read the question. Let's pretend we read it twice, because I don't want to spend too much time just reading. You can read it again on your own. Identify your knowns and your unknowns. So well, we're talking about 3 different classifications of majors. So this is kind of in the known, unknown region. We know the names are psych. I'm going to abbreviate. Then we have the business major. And then we have the English major. There we go. So those are our 3 majors, and they're going to make some amount of money. But we don't know exactly how much money they're making yet. In fact, that is the literal question at the end. What is each major's individual average? So our goal is to find these, but for now, they're unknown. They're unknown. We give them variables. Now, when I say variables, I don't necessarily mean X, Y, Z. Maybe we have to do that. Maybe in a more complicated problem, we have to do that. But we have relationships between these 3 things, and we need to use those relationships to avoid going X, Y, Z, to maybe only have a single variable to make this simpler. And here is how we can avoid that. The business major on average makes $8,000 more than the psych major. The English major makes on average $3,000 more than the psych major. So here's my super helpful, handy dandy tip. When you've got a whole bunch of different categories, like these 3 categories right here, any of them, or if there's just one of them that has nothing stated about it, then call it X. Call the one with nothing stated about it X. So the business major, blah, 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 blah. All right, so that says something about the business major. So we're not going to call it X. The English major makes blah, 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 blah. So we're not going to call the English major X. The one we don't have that statement for is the psychology major. So we're going to call the psychology major our X. Then the business major and the English majors, what we're going to do is we're going to tie them to the psych major. Now, it doesn't always work that way. Maybe it's the business is tied to the psych and then the English is tied to the business in a more complex scenario. But I already pointed out, this is a simpler one. So the business major on average makes $8,000 more than the psych major. So if the psych major earned $2,000, then that means the business major is making $10,000 because 2 plus 8 is 10. If the psych major is making, say, $80,000, the business major would make $88,000. You take the psych major and you add $8,000 to it. So that's exactly what we're going to do. That statement I just made, we're going to take the psych major and we're going to add $8,000 to it, and that'll give us the business. So the business major is going to be X plus 8,000, because X represents the psych major. And what some people might do is even write psych plus 8,000 here, and then in the next step, inject the X into it. That would just be a longer version of the same thing. So let's see if we can do the same thing for the English major. The English major makes on average $3,000 more than the psych major. So if the psych major is making 40, the English major is making 43. If the psych major is making 100,000, the English is making 103,000. So let's take the psych major, which was X, and then we add our 3,000. If you want to put the 3,000 before the X or the 8,000 before the X, be my guest. Nobody cares. It's perfectly fine because it's addition. If it was subtraction, that statement wouldn't hold true. Now I think I had some of these things. Yes, I do. Now I've done it in thousands here, and I'm going to show you a different way that you could have done this, and that's right here. So I did this intentionally. You could call the psych major X still. That's a lowercase x. That doesn't make a difference. Then the business major X plus 8 and the English major X plus 3. So doing it this way instead, we're saying that everything is in thousands of dollars. So it's just a matter of whether you want to have everything have smaller numbers in your equations, or if you want to have the numbers just labeled completely outright. Nobody is going to care how you're labeling and doing these things as long as you are consistent and can get the right answer. So if I solve it this bottom way and it turns out that X is, I don't know, 10, that doesn't mean the psych major makes 10 bucks. It means they make 10,000. So you have to correct that. So if you're going to use this version of it, please make sure you're well labeling things and pointing out that everything is in thousands of dollars. So again, both of these are excellent setups. I wouldn't care, my math lab wouldn't care which one you use. Now, if you're doing the help me solve this, it might care because you're going to have to type in the way they want. But in terms of if you're just doing a problem and all they need is the answer, that's when it doesn't matter. Okay, so I'm actually going to use the bottom version for simplicity, but I still wanted to introduce it with the top version. So now let's do the next thing that says write out an equation in words. That's going to be using this part. We've already used the identifiers in the sentence before. So now we're to if the sum of these three majors averages is $116,000. Sum means add them up. So we're going to take the psych major plus the business major plus the English major and set it equal to $116,000. So again, I'm going to do the one in thousands, which is why you just see me write 116 and not 116,000. I want to add the word or in there. I said it several times, but I want to make sure everyone gets there. So we read the question. We identified knowns and unknowns. We wrote out an equation in our words. Now let's actually put the knowns and unknowns into the equation. So instead of psych, I'm going to write X. Instead of business, I'm going to write X plus 8. Instead of English, I'm going to write X plus 3. So we get this. And from there, go away. I don't need you. Ignore. This is our equation, and I'll space this out so you can see it a little nicer. The psych major was that first X, the business major was the X plus 8, and then the English major was the X plus 3. Now here is the reason I use my words. Here is the reason that I suggest that you use your words before just going straight to the equation. This right, why am I not on highlight? I clicked highlight. Highlight. Okay, you know what? All right, the highlighter is broken. Oh, I'm not on draw, that's why. Silly me, that's my fault. This right here, this X, I have seen countless students miss it when they skip using their words, because what they'll do is they'll see this X right here, and they'll think, okay, well that X is the psych, and then the business is the plus 8. Well, no, the business is X plus 8. So you have the X for the psych, you have the X plus 8 for the business, and then the X plus 3 for the English. So that is why I'm highly suggesting you use your words. Now, do you have to? No. Am I going to take points off on a test if you don't use your words first? No. But are you going to get more right answers? Probably. So now we got to do is solve this. And I've got to show all that work. So we got x plus x plus x. There's 3 of these x's on the left side, so that'll give us 3x. Then we have the 8 and the 3. 8 plus 3 is 11. So we get 3x plus 11 is equal to 116. This is a very, very simple linear equation. I would be terrified if you can't solve this. Subtract 11 on both sides, which will give us 3x is equal to 116 minus 11 is 105. And then we just divide both sides by 3. There was no fractions, no distributions, just some like terms and moving one thing over. And what we end up with is x is equal to 35. Now, some people will box this up, ship it out, and say that's my answer, and that's not the answer. That's completely wrong, in fact. 35 is not any of the answers. Notice I just said answers, because it's not just one answer. It's multiple answers. What is each of the majors' individual average? So you have to go back and do this. I like to say what is or was, depending on past or present tense, x. That's a question I always like to ask myself. That's a question I suggest that my students ask themselves. X was the psych major. But again, this was in thousands, so that means that the psych major should be earning $35,000. So P-S-Y-C-H, 35,000. There we go. Then from there, we want to find the business and English majors, which are based on X. Well, X is 35, so just take your 35 and add 8 and 3 respectively. So your business should be 35 plus 8, which is 43. So that's 43,000. And then your English was the X plus 3, so that's 35 plus 3, and that's 38. $1,000. And there we go. Read the question, read it a couple times, understand what each sentence is doing for you. Typically, you'll have a sentence of labeling things, a sentence of your equation. There'll be a question and saying, hey, what is it you're supposed to be finding? You usually have declarative statements as well. Label your knowns and unknowns. Whether you want to do in thousands or not, these 2 versions. And then I said I use the second one. Write the equation in your words, convert your words to your knowns and unknowns, solve it via all those methods we rediscussed last time. And then, does it make sense? Is this the answer? What was X? It was the psych. So no, it's not the answer. It's one of the answers as long as you attach those 3 extra zeros. Very important details. All right, so let's move on. Before we do example 2, I want to introduce something known as the linear cost model. This is a very common model before you start getting into calculus when we want to model costs, incomes, anything like that. You have variable costs and you have fixed costs. The word variable means changes. Fixed means doesn't change. So let's pretend like we're just all in the same year. So rent isn't going to go up. Rent would be a fixed cost. So when you have a business, you probably have a building somewhere and you're going to pay rent. Your rent would be a fixed cost. The variable cost would be everything including like the materials you use. So the more items you make, the more materials you need. So you'd be paying more money for more materials. But then you'd be making more money off of that, hopefully. So materials are a variable cost. Paying your employees is a variable cost because it's based on their salary. It's based on how many hours they have. And we're not getting into all these intrinsic details, but just the basic idea of fixed and variable. Variable changes, fixed doesn't. Fixed is going to be just a number so that it's constant. Variable, in order to make it changeable, you have to attach you guessed it, a variable to the number. So this might be something, I'm gonna erase this in a second, like your total cost is equal to maybe 3x plus 500. That would say that you're paying $500 in rent maybe, and it doesn't have to be rent. I'm just saying that's your fixed cost, that's your rent that is not based on anything else. And this says that it's a cost of $3 per item, X being the number of items. So if you were going to make one item, it costs you $3 to make that item, plus the 500 in rent. If you were going to make two items, it would cost you $6, 3 times 2, plus your rent. If you were going to make 10 items, it would cost you $30 plus your rent, because 3 times 10. So we're going to use that idea. In the next example. Let me do this. Okay, I have, my spacing was weird, so I was thinking that something wasn't there for a second, but it is. Sorry about that weird scrolling. Example 2, you are choosing between two super old school cell phone plans. Plan A has a $20 monthly fee and costs 5 cents per text that you send. Plan B has a $5 monthly fee and costs $10 per text that you send. So a more modern version of this problem might be 5 cents per like megabyte of data and 10 cents per megabyte. I wouldn't go into gigabytes though, because the cost would be higher. But I like the numbers for this problem, so I haven't changed it in the past year or two. At how many texts does your plan choice not matter? So again, just some extra little details about the fixed and variable costs that we've already discussed. Fixed costs are like your flat fees, rent, things like that. Variable costs change based on quantity. So they're typically labeled as a per something. Something that's based on quantity is typically labeled as a per something. So Plan A and Plan B. Plan A has got a $20 monthly fee. It even has the word fee attached to it. So that's probably a big hint that it's a fixed cost. And then it costs 5 cents per text message. So if you send more text, it's going to cost more money. So that's your variable cost. Plan B also has a fixed and variable cost, $5 being the fixed, which is a lot cheaper than Plan A, but then the variable cost is higher. It's twice as much. That looks like ver. Make that an A. There we go. And the ultimate goal here is to find out at how many texts does your plan choice not matter. What we're looking for here is kind of like an equilibrium price in a supply and demand kind of problem. We're looking to figure out how many text messages we would need to send for the total cost of Plan A to be exactly the same as the total cost of Plan B. We want the plan's cost to match. That's going to be our ultimate equation. That Plan A's cost should be equal to Plan B's cost. That's what I mean by at how many texts does your plan choice not matter. Because the fact that Plan A has a higher fixed cost and a lower variable cost has significant, what's the word? It's important. I can't think of the other word I want to use. And comparing to Plan B having a lower fixed cost but a higher variable cost. So think about this. Let's think about if you were a person who doesn't text at all. This is just an emergency phone. It sits in your glove box like it's still 1999, and you only pull it out when you broke down on the side of the road. So if you go a month without sending any text messages, you're not going to pay for any text messages. That 5 cents or 10 cent plan will not matter, but you still have to pay the flat fee. So if you don't text at all, what would you rather have, Plan A or Plan B? Well, probably Plan B, because you're only paying $5 a month versus $10 a month. But because of the higher variable cost, every time you send a text message, you're paying twice an additional amount in this one versus the last one. So if you send one text, now you're at $5.10, whereas the other one, you'd only be at $20.05. This would have increased by 10 cents, where the other is only increasing by 5 cents. And you go, okay, well, plan B is still good. But eventually, that higher variable cost is going to come back and bite you. And this is now going to be more expensive because the variable cost is going to take precedent over the fixed cost when you're sending maybe 2,000 or 5,000 text messages. So we're trying to find the equilibrium point, basically to say, all right, where if you're going to send more text messages than this, you need to use plan A or B and vice versa for the other scenario. All right. So our total cost is our fixed cost. That was too much. Plus our variable cost. Total cost is the sum of a fixed cost plus a variable cost. Again, literally the same thing here. I wrote the fixed and variable order in a different order. That doesn't matter. You can say variable plus fixed. You can say fixed plus variable. That's why I did that. Where again, a variable cost is going to have to be multiplied by an X. So for plan A, that's the $20 monthly fee, which is fixed, and the 5 cents per text. That's the variable amount. So plan A has a fixed cost, and all of these are in dollars of $20 and a variable cost of 5 cents, or $0.05. Plan B has the $5 monthly fee, that's its fixed cost, and a 10-cent per text variable cost. So there we go with plan B. And again, all these are in dollars, dollar, 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 dollar. So we're just going to throw these two numbers into the total cost formula, which is right here. The fixed number goes right here with nothing else, then plus. The variable number has to be multiplied by an X so that's allowed to vary. So the plan A would be 20 plus 0.05x, whereas plan B will be 5 plus 0.1x, where x is the number of texts that we're sending. And I already mentioned this earlier. This is the equation we get out of at how many texts does your plan choice not matter. That means we're setting plan A's cost equal to plan B's cost. The order that you write the 20 and the 0.05 doesn't matter. If you want to write the 22nd, that's perfectly fine. And you can swap the 5 to after the 0.10x. Nobody cares. It doesn't matter. Trust me. But since the one above it says fixed and variable, I'm going to leave it this way. But again, you are more than welcome to change the order of those two terms. So setting plan A's cost equal to plan B's cost, this is exactly like setting y1 equal to y2 in one of those examples we did last class with the rational equation. Plan A is like our y1, plan B is like our y2. So doing that, this is where my work will go. You will get 20 plus 0.05x is equal to 5 plus 0.10x. Now you might be saying, why did you write the 0? You don't have to write that 0. That is true. I don't have to write that 0, but because it's dollars and cents, I just feel like it makes a little, sorry for the pun, sense to do it that way. But again, if you don't want to write this 0, be my guest. Okay, well, guess what? We have an equation and there are decimals in it. And I gave you a technique last class for simplifying equations with decimals. We say we find the LCD, which when you're dealing with decimals, it's the most number of decimal places you see. There are no decimals in the 20. There are 2 in the 0.05. There are none in the 5. And there are 1 or 2, you could argue either way, in the 0.10, because like I said, if you don't write the 0, you count it as 1. As I have it written, it's 2. But the cool thing is, it doesn't matter, because the LCD just uses the most. Whether this is 1 or 2, this one still had 2, so the most is definitely 2. The LCD is 100. If you make this too small, if you make your LCD 10, if you actually pay attention to the work, you won't clear your decimals because you'd be multiplying each number by 10, which moves each decimal right once. The 20 is fine, but the 0.05 would become a 0.5, and that's not good enough. So a 10 is not good enough. Something else that's cool, if you use 1,000 or 10,000 or 1,000,000 or 1,000,000,000 or 1,000,000,000, it's just going to make these numbers bigger in the process, but your equation is still solvable and still completely accurate as long as you do everything correct. Anything you can do with an LCD, you can do with a CD, a common denominator. It just makes the math more difficult. So we're going to multiply each term by 100. I'm going to go ahead and write my 100 times as. So I don't have to keep switching back and forth between colors. So 100 times the 20 plus 100 times the 0.05x equals 100 times the 5 plus 100 times the 0.10x. That'll make each decimal go right twice. So I'm going to erase any decimal movements you see in just a second. So the 20 goes right twice. There'd be 2 filler zeros. That's now a 2,000. The 0.05 will go right twice, so it's now a 5. This 5 will go right twice, so it's now a 500. And this will go right twice, so it's now a 10. So what that gives us is 2,000 plus 5x equals 500 plus 10x. No more decimals, much easier equation, much easier on the brain, the eyes, everything. So we can solve this now. I mean, we were still solving it in the step before, but I feel like we're probably more ready to solve this. So we want all the x's on one side. There's more x's on the right, so me personally, I would subtract 5x on both sides. But if you prefer to subtract 10x, that just means your next step will be opposite of mine. Then, if the x's are going right, I need the constants to go left, so I'll subtract 500 on both sides. $2,000 minus 500 is 1,500. These will cancel, but again, I don't like leaving that there. Equals the 500s cancel. 10x minus 5x is 5x. Only one more step, that's just a number times a variable, so we divide both sides by the number, divide both sides by 5. So that these 5's cancel. And 1,500 divided by 5 is going to tell us, so I don't like to do it that way, that x is equal to 300. Someone asks, is the LCD a required step or does it just make this easier? They answered their own question. It just makes it easier. You can do this problem without identifying the LCD, but some of you might have a little more trouble. So on a test, if you solve this without doing the LCD, you'd still get full credit. Your work is perfectly fine. But especially when you're dealing with fractions, I highly suggest that you're doing the LCD. And again, if you can somehow solve it without showing that one particular step, that's okay, but it really does make it easier. It lessens that burden. All right, so we got our x. Thank you for asking that. What is x? So we go back and we say x was the number of texts. See, I know what it is because I labeled it. Believe me, I'm a classic lazy mathematician. I want to do shorthand notation for tons of things. I want to not label things. I want to just do it in my head if I can when I'm doing things on my own and not a teacher. But these are still important things that I still do even though I don't want to. Because when you go to asking this question to yourself, that might not have been phrased properly, but you know what I meant to say. When you ask this question, it's really awesome if somewhere it says exactly what it is. So 300 texts is our answer. If you don't trust this, you could plug it in to right here and see if the answers agree with each other, the planned costs. So 300 times 10 cents would be $30. 30 plus 5 is 35. If you do 300 times 5, you're going to get $15. 15 plus 20 is 35. So you can even take this concept and run with it and say, all right, well, because of the low fixed costs, if you're not going to send any text messages or anywhere up to 300, plan B is better under 300, but plan A is better over 300. You could graph these equations as lines and see that very clearly as well. And if you don't get that the fixed cost determines this, you can just plug in a random number like 10 text messages or 100 text messages, something less than 300, and it would show you that B is better, and it will always be better for anything from 0 to 300. And then it flip-flops to A being better after that. So emergency phone, I'd go plan B. If I'm going to send 5,000 text messages a month, I'm going with plan A. And there we are. So a very classic problem in regard to the actual material and how many people are actually paying per text message at this point in the world, but it's still a great idea. The fun thing is when I first started teaching way back in the day, not that far back, but back far enough for me, I would do this plan with minutes instead of text messages because people weren't really texting that much back in 2007. 2006. They were just starting. All right, let's move on. Your local computer store is having a not a good, not a great, not even a grand, a terrific sale on digital cameras. After a 40% price reduction, you purchase a digital camera for $276. Now, we're going to assume that there's no sales tax here. We're going to ignore that aspect. It would just complicate things a little bit. But our ultimate goal is to figure out what was the original cost before reduction. So maybe we're just curious. Maybe we remember paying $276 for this camera because we can see that on our receipt, but maybe we don't use it at all. Maybe it's still brand new in box and we're going to flip it online. So we want to know what the original price was and then maybe mark it down 10 or 15% from that. Maybe we just got this on a super steal off of Newegg or something like that. And again, there could be lots of other reasons to want to do this. I'm just trying to give relevance to these problems, something that you might have in your own real life. So I have nothing typed up for this one. We have a 40% reduction and a final sale price of $276. That's our knowns and unknowns for now. So we have our 40% reduction, final sale price of $276. And then what was the original cost before reduction? Well, that's our goal, our original cost. We know nothing about it for now, so we call it X. Now, hopefully we all understand the idea of a sale. A sale reduces an original price. So a final sale price is going to be the difference of the original price, difference meaning subtract, and a discount amount. Now tab over a little, I'm going to say where discount equals. Now, it's not just take the original price in dollars and subtract 40%. That's not what a discount is. It's not for subtracting 40%. You can't take a dollar amount and subtract 40%. A discount is a percentage of an original price. Of, in math, that word generally means multiply. And generally, that's just how percentages are. We take a percent of something. So a discount is equal to the reduction times the original price. So this is I called it a reduction here. Some people might call that discussion. Some people might call that the discount rate. So there's an alternative name for this, reduction or discount rate. But you have to be very careful saying this. And if you go in a store and you ask an employee, they're going to say it's a 40% discount. If you ask some random person on the street, they're going to say it's a 40% discount. But as pre-calculus students, we need to understand that a discount is actually a dollar amount. A discount rate is the percentage. So if you wanted to be snotty, you could then correct people in a store, and that's not what I'm suggesting that you do. Nobody really cares about phrasing of words and when they're talking, right? I certainly don't. If someone asked me, hey, what's the temperature outside right now? I'd say it's 83 degrees. And that's completely wrong. It's 83 degrees Fahrenheit. So even your math teacher will intentionally misspeak sometimes because it's just how people are. I mean, we talk different ways than we act, but we have to know how to act and react in the math. So this is kind of like, it feels like a system of equations because there's two things, but really you can just substitute reduction times original price into this and it gives you what you need. So you could say final sale price is the original price minus the reduction times the original price. These are not some kooky, crazy formulas. This is us just developing a concept using very basic ideas. A sale means subtract two things. A discount is a percentage times the original price. But it feels a little more complicated because we're putting one thing inside of another. All right, so what exactly is it we know and don't know? We know the reduction is 40%, so we're going to put a 40% here. We don't know the original cost, it's an X, so we're going to put an X here and an X here. It goes two spots. The final sale price we know is the 276, so that's what goes there, and that will fill out our equation. So we get final sale price, $276 equals original price, that's our X, minus the reduction. Now the reduction is 40%. Can I just write 40% here? Well, if this was Excel or another computer program potentially, maybe, but we can't do that with an actual equation. We're doing it by hand. So we got to make sure that we convert this reduction to a decimal. And 40% is a decimal. You just take the decimal, move it left twice, and you'll get 0.4 or 0.40. I'm going to go with 0.4. But again, you could call it 0.40 if you prefer, but we did that in the last example, so I would just want to change things and do it differently this time. So reduction is not 40%, it's 0.4. Original price is still X. And we have our equation. Now, there are two ways you can go about solving this one, just like there were two ways you could go about solving the last one. Just going to scroll up for a second, I'll come back. This had decimals, so your teacher said it's probably best to get rid of the decimals, so we did the LCD of 100, we multiplied everything by it, and we got rid of the decimals. So that's the way I'm going to do it again. But I will also show you something after the fact for this problem, because I know some of you are just going to want to combine these, and you're going to say x minus 0.4x is something that's wrong half the time, unfortunately. So I'm going to come back and I'm going to redo this problem at the end. But for now, LCD, 276 has 0 decimals. There's an imaginary little 1 right here. Remember that there's always a 1 in front of a variable if no other number is there. So there's no decimals there either. And this has 1 decimal, which means our LCD is just 10. I could use 100, and if I wrote that as 0.40, I might count it as 100. I could use 1,000, and they'd all get the right answer. But we're doing this as simple as possible. So we use the LCD, not just a CD. Make sure your decimals and your multipliers are really well labeled. You don't want to actually think this is 10.04 or 10.0.4. That would be weird, right? Each decimal goes to the right once, which makes this 2,760. This is a 10x, and this is now a 4x. 10x minus 4x is going to give us 6x. Oops. We're up. Go. So this will be 2,760 is equal to 6x. You're then going to divide both sides by 6. Remember, test 1, you are not allowed a calculator. So you got to know how to do this division by hand. Is this the end of the world? I certainly hope not. So maybe you show your division to the side. Probably the only time I'll ever do this in a pre-calc class. 6 can't go into 2, but it can go into 27 4 times. 4 times 6 is 24. Subtract, you get 3. Bring down the 6. 6 goes into 36 6 times. 6 times 6 is 36. Subtracts perfectly. When you bring down the 0, it's going to divide into 0, subtract 0 is 0, 0, 0. So 460 is our answer. What is x? X was the original price, the original cost. That's the answer we need. So there's nothing else we have to do this time. That's kind of nice. That wasn't the case for the first problem we did. So $460 was the OG cost, the original cost, the sticker price, whatever you want to call it. When you get your answers, ask if they make sense. If you got an answer that was $4,000 here, that wouldn't make sense. How did you go from a $4,000 camera to only paying $276? That sounds like you got a 95% discount. That sounds like this camera was tucked away in a store that was having a fire sale and someone just hadn't seen it and it got marked down like crazy because of that. If you got an original price of, say, $100, that absolutely would not make sense either, because how is the original price lower than the sale price? It sounds like someone at the store has messed with you. So make sure that they're sensible. Okay, so 40% is about 50%. So 460 is about 500, 276 is about 250, and yeah, they're about twice each other if you do it that way. You can round these numbers out just to kind of see if they play correctly. Going back to this, 300 text messages. I did mentally or verbally plug it in and confirm that they were the same. So that was me making sure it made sense. With this earlier problem, if I had gotten answers of $35, $43, and $38, that wouldn't make sense because I disregarded the thousands aspect. Or maybe I got answers that were 200,000, 17 million, and something else. That wouldn't make sense because they definitely didn't add up to 116,000. And you definitely don't have primarily on average English, business, and psychology majors making millions of dollars. Maybe some business majors, maybe some psychology majors, maybe a couple English majors, but not on average. So make sure things make sense. All right, example 4. Bob invests 50 grand into 2 accounts, earning simple interest, which is not typical, but just go with it. Sorry, I had a really quick distraction. Bob invests 50 grand into 2 different accounts, earning simple interest. No savings account earns simple interest in the entire world except on a day-to-day or maybe a month basis, depending on how they're doing what we call compounding their interest. All accounts earn compounded interest. We only do simple interest on one compounding interval or in a problem like this just to keep things simple, because compound interests have hairier formulas that we kind of get to in chapter 4. After a year, Bob earns $6,000 in interest between these 2 accounts. I'm not saying he earned $6,000 in each. I'm saying $6,000 in total. Maybe it was $3,000 each. Maybe it was $2,000 and $4,000. Maybe it was $1,000 and $5,000. Maybe it was $500 and $5,500. I don't know yet. If he invested into accounts earning 7% and 15% per year on simple interest, how much did he invest in each? So as a reminder, your simple interest formula, which is a dollar amount, is a product of the principal, the interest rate, and the time, PRT. So I equals PRT, party time. So we're going to have 2 of these, one for each account, one for the 15% account, one for the 7% account ultimately. And I'm actually going to do the equation first this time in words, just because I think it's a little cleaner to do it that way. So I can save it for a little bit later, a few lines later, but I'm going to go ahead and get it out of the way because I feel like since it was the second sentence and setting this up might be a little more involved, it's just better to go ahead and do that. So Bob earns $6,000 in interest between these 2 accounts. So the interest on the 7%, let me do the 15% first, actually. It doesn't technically matter. Interest from the 15% account plus the interest from the 7% account, that should total $6,000. In order to calculate the interest from each of these accounts, we need the principal. Principal is the amount invested. We did not put $50,000 into both of these accounts. We don't even know how much we put into these accounts. Maybe it was $10,000 and $40,000. Maybe it was $1,000 and $49,000. Maybe it was $25,000 and $25,000. We weren't told any relationship at all between these. And this brings us to a very, sorry for the pun, interesting concept. So since we don't know how much we put into each account, there's going to be variables involved. So the principal at 15%. We don't know what it is at all, so we call it X. Principal at 7% though. Some people might call this Y, and you can do it that way, systems of equations, but we're avoiding it for now. Let's do this a different way. Let's actually think about this. I said some numbers a few minutes ago that make sense, I hope. I said you could put 10,000 in one, but that means 40,000 has to go in the other to sum to 50 grand, or 1,000 in one of them, and then 49,000 in the other because 1 plus 49 is 50, or 25 and 25. Because 25 plus 25 is 50. And there's literally billions of different ways they could be split up. We don't know how they're split up yet. That's the goal. So let me ask you this question without saying both of those numbers. If I put 10,000 into the first, how much do I have to put in the second, given that we invested 50 grand? Well, you have to put 40 in. How did I figure out that 40? I took the 50 and I subtracted the 10. So I took the total and I subtracted the first. 50 minus 10. Or maybe it was I put 1,000 in the first account, so I do 50 minus 1 is 49. Or if I put 25 in the first, 50 minus 25 is 25. Each of these times to get the second amount, I'm taking the total and subtracting what I put into the first. So the total is the 50,000. This was the total. What we put into the first is not the 10,000 or 1,000 or 25,000, it's the X. So these are the two things that we have to subtract. And I'm going to write out the words for that after the fact. So the principal at 7,000 would be the total of 50,000 minus what we put in the first, which was X. We don't know what we put in the first. So to the side, this was the total minus the first. This right here, I'm going to highlight and I'm going to leave it highlighted because this can pop up. This I was trying to combine the words pop and crop. This can pop up, it can creep up at any point throughout the semester. This is a very important concept. And it's not just with investments. It's all right, I've got a 12-foot long piece of wood and I cut it somewhere. What are the lengths of each piece? I can call the first one X and I can call the second one 12 minus X. That would be a really good thing since I don't have any other type of relationship between the two. All right, so now that we have our knowns and unknowns labeled, we have our interest equation that interest 1 plus interest 2 is 6,000. Let's actually show what those interests are. So the interest from the 15% account, that would be the principal times the rate times the time, which is X times, that was the principal, times the rate, which was 15% or 0.15 as a decimal, times the time, which is 1 year. PRT. And let's just clean that up. 0.15 times 1 is 0.15. It's better to have that in front of the X, so we get 0.15X. That's the interest from the 15% account. Interest from the 7% account is going to look similar but different. I'm going to write this incorrectly at first. So the principal is the 50,000 minus the X. This is going to be wrong, but just hold your horses, and I'll show you why. So there's my principal, times the interest rate, which was 7%, that would be 0.07 as a decimal. And herein lies the problem. We're supposed to be multiplying all of the, we're supposed to be multiplying all of this by the 0.07, but because it's a subtraction, it only looks like the x is multiplying the 0.07. So what that means is we need to introduce a parentheses around the 50,000 minus x because of the multiple terms. Oops. Go. So there's the principal in parentheses, the 7% is the 0.07, and then times the time, which is also 1. I'm actually going to put this on a second line because of that. So that's equal to 0.07x. So it is these two things. This is the interest from the 15. What did I get? What did I do? What did I do? I did that wrong. It's not 0.07x. It's 0.07. Sorry about that. 0.07 parentheses the 50,000 minus x. I was looking somewhere else. That's on me. So this is the interest amount from the 15% account. This is the interest amount from the 7% account. That's going to get plugged into here, and here that will then set equal to the 6 grand. So we're going to take the equation, and we're now going to get the interest from the 15% account, that's the 0.15x, so 0.15x. And plus the interest from the 7% account, which is this 0.07 times 50 grand minus x. And we set that equal to 6,000. And we solve. Uh-oh, more decimals, more decimals. It's like they never go away. So what we need to do is distribute. If you remember the instructions from last time, and I'm not going to open the file, refer to your notes from last class from 1.2, those 4 steps that I said, the order can be arbitrary, but I did suggest that you distribute before going to clear your fractions or decimals. So I need to give that 0.07 to the 50 grand and to the x. So that'll be 0.15x. I'm going to stop using my pen because it takes too, I'm going to start using my pen because the other way is too time consuming. The 0.07 times 50,000, I'll let you confirm that this is going to be 3,500. 7 times 5 is 35, and then it's just a matter of zeros and decimals. Then minus the 0.07x equals the 6 grand. I see decimals, so let's go ahead and find our LCD. Some of you might want to go ahead and combine those like terms. You certainly can. There's no problem with that. So I could do my LCD now, which is going to end up being 100 because 2 decimals, that's the most. Or I could wait, and I am actually going to wait this time, just one time, because I know a lot of people will go ahead and want to combine this guy with girl with girl, whatever. 0.15 minus 0.07 is going to be 0.08. You're going to have to line up the decimals vertically if you're going to do your math like that. 0.15 minus 0.08, 0.07, excuse me. That gives us the 0.08. So that's 0.08x plus 3,500 is equal to 6 grand. Now in that idea, maybe some of you want to go ahead and move the 3,500 since these are both wholes. If these are both wholes and you know how to subtract them, you can certainly go ahead and do that and wait one more step for the LCD. So I'll do that. I'll subtract 3,500. Again, I can multiply by 100 at this point if I prefer. It is up to you as a student. There's a million ways to get the job done. So we get 0.08x is equal to 2,500. Some of you might know how to go ahead and divide by 0.08, and again, that's fine. But now I'm going to actually do my LCD business, which is still 100 because 2 decimals are here and none are here. So we'll take 100 times the 0.08, 100 times the 2500, which just moves each decimal right twice per usual. So if this goes right twice, you'll get 8. If this goes right twice, you'll get 2 more zeros. Should be 25 or 250,000, right? So that's 8x 0. Yes, 250,000. We divide both sides by 8. And if you do that long division, let's see, 8 will go into 24 3 times, then that'll be a 1. So 31250. Again, I will leave it up to you to confirm this. We don't always have time to show the long division in class. But then you go back and you ask, what is x? X was the principal at 15%. That was one of the two questions we were asked. What is the principal at 15%? What was the principal at 7%? So the 15%, I'm going to abbreviate, principal is $31,250. But that's not the only thing we need. We also need the 7% principal. So how do we find that? Well, right here. It was 50,000 minus x because they have to add up to 50,000. And if you do 50,000 minus 31,250, you'll get $18,750. So those are our two answers. Make sure they're in correct answer blocks in my math lab. You don't want to miss points because of that. It's another case of if it's a test, I'll give you partial credit if you let me know about it. But I don't even know that I'd give you full credit because as pre-calc students, you have to be paying attention. I'd probably give you like 4 to 5 points if your answers are just in the wrong blocks. We got 15 minutes. All right. So that's going to be it for the word problems, but we're not done with 1.3 yet. We have one more small topic to cover. Please don't mess this up. It's going to mess it up. All right. So let's see if I insert a new page.
Yeah, the thing that I just said, please don't mess up. It messed up, so I'm just going to skip over a little technical issue.
This is still 1.3 at the beginning of something so that that doesn't happen. It's a bigger problem than it should be. All right, formulas, also known as literal equations. This is still 1.3. Formulas, aka literal equations. You might say, well, we were just dealing with formulas. But when we call something a formula, this is before we actually go plugging numbers into them. So you'll handle these as if the variables in them are numbers with the exception of the one you're asked to solve. So you'll handle any variable not being solved for as a constant. There is more than one of the variable solved for. You will likely have to move it to the same side and factor it out as a GCF. V. No idea what a GCB is. GCF. What I mean is you might have an equation that looks like V equals LWH. That would be the volume of a rectangular solid. It's the length times the width times the height. And I might ask you to solve it for the height. So you have V equals LWH, and I don't give you any numbers. It's just 4 letters. But that H can still be solved for because it's multiplying the L and the W, two things that we're going to count as constant even though they're not. So you divide by them. Just like we can move an X to another side, you can divide by things that are variables as well. But what you'll see in later examples, maybe today if we have time, I'm not sure yet, is that sometimes maybe that variable's in 2 spots and on opposite sides. So you might have to move them to the same side and then factor it out as a GCF because you won't be able to combine them. What I'm talking about here is if you had something like 3y plus 5y, that's 8y because they're like terms, 8y. But if you had, say, xy plus AY, they're not like, so you can't combine them. But instead, what you can do is you can factor out that common variable as a GCF. You can take that y, open a parentheses, and divide it out. If you take the y from the first term, you'll only have the x left over. If you take the y from the second term, you'll only have the a left over. So the top is combining like terms. This bottom one is factoring it out as a GCF. It just depends on your scenario. These aren't like terms because x and a are different variables. 3 and 5 are numbers. That's perfectly fine. They can be different. All right, what are we up to? Example 5, right? I'm pretty sure example 5. Solve with a specified variable, specified variable. And for A, we're going to have P equals 2L plus 2W. This is the perimeter of a rectangle, something that you should have memorized. If you don't memorize it, then you should know what a rectangle looks like. They have lengths opposite each other, widths opposite of each other. Perimeter is just adding all those things up. So add them up. 2 L's, 2 W's. And we're going to solve this for, which one do I want to do? It doesn't matter. Let's do L. Here's what I like to do at the beginning of a problem. And again, you're going to see me erase this. So maybe write this down as a memo in your notes because you're taking notes, right? I like to circle the variable we're solving for. This says, hey, look at me, solve for me. Everything else needs to go away from me. I'm sick. I've got COVID-19. The 2 and the 2W need to get away from me. The flu, cold, whatever, anything that's contagious. Not trying to make light of a situation. Please don't be offended. So that's the variable we're solving for. So everything else counts as a constant. This P, I can in my head pretend this is a 10, just don't execute it as a 10. This 2 times W, I could pretend that's another constant. So you still need to follow those 4 rules: distribute, combine like terms, clear fractions, move things from side to side, then divide by the variable at the end. There's no distributions, there's no like terms, there's no fractions, so we got to go to moving things by adding and subtracting. So this 2W and this 2 are what need to be moved. The first 2 is multiplying, so that'll have to wait to the last step. This 2W is adding, so we'll subtract it to move it. So we're going to subtract 2W. And this is, in my opinion, poor notation, but I will always do it this way because I know most students do it this way. I have put 2W under the P, kind of implying that they're like terms, but they're not. In a perfect world, I would have rewritten this equation with some space next to the P and then put the 2W under that space. But still, I hope you know that P minus 2W, you can't do anything with that. Then equals, we still have the 2L, but these two W's cancel. So the side with our quote variable, the one we're solving for, is fine. It's got less stuff there. Now we just got to focus on getting rid of the 2. Again, the thing we're solving for is this L. I don't care how messy this side is. I'm just going to pretend in my head that it's a 100. So if I had 100 equals 2L, I'd divide both sides by 2. Guess what? The ugliness does not affect the algebra. Divide both sides by 2. So what we get is P minus 2W over 2 is equal to L. You see these 2's cancel on the right-hand side, like that. But these 2's do not cancel because we would need another 2 here. We would need another 2 to be able to cancel all of them. You can't just pick and choose which ones you're going to cancel. So this is a slightly common issue with students, that they'll want to cancel these 2's and you won't have that 2 here, this 2 here, and they'll think it's just P minus W, and that's wrong. So this is one of the answers. And again, no, you cannot actually cancel these 2's in this form. However, you could split it. Split the fraction. What that means is you'd have P over 2 minus 2W over 2. Just take each top and write it over the given bottom. Bottom equals L. Now sum cancel. these twos would cancel, but not the one with the p. So you would get p over 2 minus w equals L. This is also a 100% acceptable answer. I don't care which way you do it. I don't care which way you write it. But if your answer is p minus w equals L, I do care because it's wrong. It's very, very wrong, in fact. This is a concept, that canceling of multiple terms in a fraction. We will be addressing this multiple times throughout the semester, so buckle up. I think we only have time for one more. A equals B plus C D E, and we're going to solve this for D. I'm going to have to speed up about 5%. In a normal class, I would have finished this lecture today, but we have 2 more problems to do before we can call it finished. And that's just a product of how we're teaching. So just note that I might have to go 5 to 10% faster in the future. I'm really trying to slow things down and take my time, especially since you're not in front of me, and that might make it harder to learn for some people. But remember, there's always the replays, and I'm sorry if I go a little quicker. And the nice thing is the replays, you've got the slow down buttons. You can slow me down to 75% speed. I also got to rant less like that, but I don't know. I feel like it's a critical rant. Solving for D. Which one are we solving for? This one right here. So the B, the C, and the E gots to go. So the C and the E are multiplying, so we'll have to divide that, but that's generally best as a last step. This B is being added or subtracted. It counts as being added because this is a positive, so I'll subtract it. If that was a negative, I'd add it. So let me subtract B on both sides, and again, I am doing this not exactly properly visually, but nobody cares because this is how everyone does it. So the left side, A minus B, I have no idea what it is. Again, I hope I'm not insulting anyone, but I call these the hipster problems of math because they look a lot more complicated than they actually are, because you never really do any arithmetic with them. You just say move it, and you don't have to combine it. You don't have to divide it. It's just there. So that'll be equal to CDE. Again, the thing I'm solving for is the D. So the C and the E got to go. And I can actually do that in one step since it's just one big product. So I can divide both sides by C and E. Let me make that E a little nicer. It's not the prettiest E. There we go. So what that'll give us is A minus B divided by CE. I have absolutely no idea what any of that is. There's no numbers, so you can't reduce it. That's what I meant by the hipster. It looks more complicated than it is. The C's on the right cancel, the E's on the right cancel. And that just gives us our D, and this is the answer. There's no real better way to write this one. And in the previous problem, I wouldn't say either of these is better than the other. When we get to linear algebra, like graphing lines and stuff again, I would say the idea of splitting and reducing is better for that, so you can see your slope and intercept. But when we're dealing with problems at this, in this section, in this material, I actually prefer this one on the left a little more. But again, they're both right, 100% right, full credit, won't matter. So we will pick up with 2 more of these next time. We will do C and D in class on.
All right, so that's going to be it for today. So as I was saying, we're going to pick up with C and D next class, and that will be it for the section, and then we'll go right into 1.4. So please make sure that you work on your 1.2 homework, which is due in 5 days, which is the 26th. And I would highly suggest to go ahead and get started on 1.3 as well. That way you're just ready to go. Keep pushing ahead. Email me if you have any questions, and we will see you on Tuesday. Take care, everybody. Have a good weekend.